In lesson 5, we're going to talk about how to solve radical equations. So basically what's going to happen is you're going to have something like example 1 down here, where it's going to be a square root equal to some other number, some other expression. And in order to get rid of the square root or to undo something that's been square rooted, you're going to have to square both sides. But we have to pay attention to this property up here, because if both sides of an equation are squared, the solutions to the original equation are solutions to the resulting equation. However, when we square both sides, we may gain some false solutions. Now, you'll never lose the real solutions, but we can gain these false solutions. So what that means is we always need to check when we're using this squaring technique to both sides. So always check your solutions for problems that involve a square root. These solutions, these extra solutions that we gained, are called extraneous solutions. And they're just solutions that satisfy the squared equation, but they do not satisfy the original. So they're extra solutions. So we have to check for those. So what's going to happen when we go to solve this example is we're going to start off by isolating the square root, and then we're going to square both sides of the equation. I want to undo the square root. So when you square something that's been square rooted, you're just left with what was underneath the radical to begin with. So 3x plus 4. And then I actually square the 5, I get 25. So then you just solve this equation, 4x, by bringing the 4 over to from both sides. So I have 25 minus 4 gives me 21. Get x by itself by dividing by 3. So we get x equals 7. But before I can confirm that that actually is a solution, we need to check it. So you go back to the original without the squared part, and you're going to plug in the 7, and you want to see, does the left-hand side equal the right-hand side of that original equation? So underneath the square root, I'm going to have 21 plus 4. So I'm going to see if that equals 5. So we get the square root of 25, which the square root of 25 is 5. So that means it does check, and x equals 7 is a solution. Looking at the next example, we're going to do the same process. We're going to square both sides. So we have 4x minus 7 equals 9. Remember, when you square a negative, it becomes positive. Add the 7 to both sides, so we get 4x equals 16. Divide everything by 4, so we get x equals 4. Now, before we can move on to say that that's a solution, you need to actually check. So plug in 4, and you want to see if that equals negative 3. So we have 16 minus 7. So I'm just going to go ahead and simplify the left-hand side here and see what we get. So we get 3. And again, remember, I was trying to see, does it equal negative 3? And 3 does not equal negative 3. So what that means is x equals 4 is not a solution. So therefore, the answer to my question is that there's no solution. So there's no solution to this equation. If you go back and look at this original equation, you can see that it doesn't make sense to begin with, because the square root of something can never equal a negative number. So if you recognize that right from the beginning, you don't even need to go through this whole process. You can just go right into saying that there's no solution, because you can't take the square root of something and ever get a negative. So let's look at some more examples. So for this one, again, I want to isolate that squared root term first. So I'm going to bring the minus 3 over. It just makes your math easier so that you don't have to square this entire thing. So I'm going to have 5x minus 1 equals 4. And now I'm going to go ahead and square both sides. So I have 5x minus 1 equals 16. Add the 1 over. So 5x equals 17. Divide everything by 5. So we get x equals, it's not going to come out evenly, so I'm just going to leave it as a fraction. And now I'm going to go over here and I'm going to plug into my original. So I have 5 times 17 over 5. minus 1 plus 3, and I'm trying to see if that equals 7. So I'm going to simplify the left-hand side here. So right here, the 5's are going to cancel. I'll be left with 17 minus 1, which will be 16. And then the plus 3 is outside of the radical. I'm trying to see if this equals 7. So here I'm going to have 4 when I square root 16 plus 3 equals 7. Combined, we get 7 equals 7, so it checks. So x equals 17 over 5 is a solution. When you're doing these checks, just make sure that you're actually just simplifying like the left-hand side and seeing if it equals the right-hand side. You should never be moving one thing from one side to the other because you're just trying to simplify to see if the two sides of the equation actually match up to make it an equation. So you don't know if it's an equation until it actually works. So let's look at some more. In this case here, I said isolate the squared term or isolate the square root terms, but in this case I can't really isolate either of the square root terms because if I move the 3 over to the other side, it's still going to be grouped. So in this case, you're going to have to just square it as is, and it just means that there's going to be an extra step when you square that you're going to have to use that box to multiply this stuff out. So here I'm going to have just x minus 3 because I'm squaring an entire square root term. But on this side, I can't distribute this squared because my operation between the two terms is subtraction. So this is actually one of those examples that we looked at in a previous lesson where you have to use the box to multiply this. So we have the square root of x squared minus 3, square root of x minus 3. So you multiply these terms, you're going to have the square root of x squared minus 3 square root of x minus 3 square root of x plus 9. So here I'm going to have just x, these terms when you group them, minus 6 square root of x plus 9. So I'm going to take this and it's going to go back into my equation. So I'm going to have x minus 6 square root of x plus 9. And now you notice that I still have a square root in here, which means I am going to have to square each side of the equation again. But before I do that, I want to isolate it so that I don't have all of this complicated pieces to multiply. So I'm going to group my like terms. So let's bring this x over first. So we have those x's canceled. So we have minus 3 equals negative 6x plus 9. We can go ahead and bring the 9 over. So we have minus 12 equals negative 6 square root of x. And then again, let's isolate the squared term. So I'm going to divide everything by negative 6. So I get 2 equals the square root of x. And now in order to get x by itself, you're going to have to square both sides. So 4 is actually going to equal x. However, we need to check this and see if it actually works. So I am going to plug in my solution into the original. So I have 4 minus 3 equals 4 minus 3. I'm trying to see if this is true. And again, simplify one side at a time. So I simplify the left-hand side, I get square root of 1. I want to see if that equals 2 minus 3. So square root of 1 is 1. I want to see if that equals 2 minus 3, which is negative 1. So 1 does not equal negative 1, which means this is not a solution. So my answer is no solution. Okay, so for this example, we need to start off the same way where we need to isolate the squared term and in this square root term, and in this case we cannot get the square roots completely by themselves, so we're just going to square it as is. So over on the left we're going to have x plus 1. On the right hand side we are going to set up the box for this, so we're going to have x plus 2 under the square root minus 1, x plus 2 under the square root minus 1. When you multiply these, you're going to have x plus 2 all squared underneath the square root. You're going to have minus x plus 2 minus the square root of x plus 2. Multiply these, you're going to get plus 1. So when you simplify this, this term here will become just x plus 2 because the square and the square root will cancel each other out. You'll have minus 2 square root of x plus 2 and then a plus 1. So when I combine my like terms here, I have the 2 and the 1. So I'm going to have x minus 2 radical x plus 2 plus 3. This is going to come back up here. So I have x minus 2 square root of x plus 2 plus 3. And now you're going to combine any like terms that we have. So I'm going to subtract the x's over. I'm going to subtract the 3 over. So these x's cancel. These 3's cancel. I have minus 2 equals negative 2 square root of x plus 2. Again, remember my goal is to isolate that square root because you need to be able to square both sides again. So I get 1 equals the square root of x plus 2. And now that I've isolated that square root, I'm going to square each side again. So I have 1 equals x plus 2, and I'm just solving for x. So we get negative 1 equals x. So now we're going to go ahead and check the solution. And when you do that, we're going to plug in negative 1 for x, and we're going to see if the left-hand side equals the right-hand side when we do that. So I plug into the original. Here I'm going to have the square root of 0. Here I'm going to have square root of 1 minus 1. So on the left it's going to equal 0. On the right it's going to equal 1 minus 1, which ends up giving me 0 on the right, 0 on the left, so it checks out. X equals negative 1 is a solution. And our last example here. So for the last example, we are going to look at a cube root problem. So now I have something where it's the cube root of 4x plus 5 equals 3, and what I need to do is I need to undo a cube root. So the opposite of cube rooting something is cubing it. So I'm going to cube each side instead of squaring it. You would do the same thing if you had an expression with the fourth root. You need to undo the cube root, so you cube it. So here I have 4x plus 5 equals 27. You're going to subtract 5 from both sides. So we have 22. Divide everything by 4. So we have x equals 11 over 2. And then again, we're just going to check, make sure this actually works. So we're going to plug in 11 over 2 and see if it equals 3. So when I plug in 11 over 2, this is going to become 2 up top. So it'll be 22 plus 5. I want to see if that equals 3. So the cube root of 27, I want to see if it equals 3. So cube root of 27 is equal to 3, so it checks, and 11 over 2 is a solution. So that's it for solving radical equations. And again, remember that you can apply that same process where wherever the root is or whatever the root is, you just raise it to whatever that power. And then the next thing we're going to look at is what happens when you take the square root of a negative number.